Today we're going to be going over low-level prognostic charts and high-level, and we'll start with the low-level. So, the low-level prognostic charts are very valuable. The reason you would use them is because they provide significant weather forecasts and weather conditions in the lower atmosphere, which is typically up to 24,000 feet. This information is very important for air traffic control, meteorologists, and especially pilots. This helps them identify potential hazards such as low visibility conditions, significant weather, and it helps to allow them to know the location and intensity of these hazards, and it actually allows them to adjust their flight plans to avoid them and prepare for potential challenges. So the valid time for this specific chart we're looking at is actually 12 hours, which we'll jump over to the 24-hour valid chart right after this. But as you can see, the regions with the ceiling being less than 1,000 feet, you see one right in the middle of California, up in Washington, and in the southern states starting on the bottom of Texas. As you can see, there are some regions with turbulence, specifically over the Pennsylvania up to New York, kind of from Georgia, all in that area. Looks like the top is 24,000 feet and the base is at about 5,000 feet. We'll hop over to the 24-hour valid chart right now because as you can see, the turbulence is basically the same. And as you can see, it's one single hat, which means it's just moderate turbulence and not severe. As far as the freezing levels go, as you can see, it's kind of a mixture at the mean sea level and at the surface. But starting up in Washington, kind of sweeping down past California through Nevada, touching the top of Texas, and kind of going through over to the very East Coast, just the very bottom part of the United States. There's actually a mixture of both of them, but as you can see, the freeze levels above the mean sea level kind of swoop down through the middle of Texas there, through the southern states more, so there is a break up there. As far as thunderstorms go, there are no indications of any storms or thunderstorms brewing, which honestly isn't that surprising because we're just over the mainland of North America, or as we call it, the United States. Even looking down there, kind of on the tip of Florida, anywhere down there, there's nothing, no L's or no lifting symbols or anything showing any thunderstorm activities as of this moment. So that will be everything for the low level. So now we'll hop over to the high level prognostic charts and go over those. So the high level chart was actually too big to fit onto one screen. So for the first half, I'll have the top of the screen, and on the bottom, I'll have the bottom. Basically North America first and then South America for the second part. So why would we use a high level prognostic chart? Well, you see, it's the exact same actually as the low level, except for instead of being below 24,000 feet, it's above 24,000 feet. And it's giving the same type of critical information, which is high level significant weather. And it just gives detailed forecast of weather conditions at those high altitudes. And again, it's crucial for pilots, air traffic controllers, meteorologists. And basically it helps identify potential hazards and basically tells pilots where they need to go to avoid these locations and to set their route. So looks like the universal time is 6 a.m. on the 6th of December, 2024. I believe the valid time was about 6 hours for this chart. And as you can see, those thunderstorms in looks like the Atlantic Ocean, and also now that we jump down here into South America, they're spread all throughout the top and middle of the map. Looks like the mainland of South America, but those are all thunderstorms. For all those thunderstorms, the triple X's that you see on those little white boxes shows that it's below 25,000 feet is where it starts, and it goes up to about 4,500 feet, 400 feet, 4,200 feet. It's all kind of jumping around. If we go back, look up at the top map, the tops of those thunderstorms, I think the highest I saw was 3,800 feet. Then there was another one at like 2,800 feet. So it just varied between those two. Turbulence is indicated by the yellow dashed line areas. On the South America chart, it looks like they'll go up to about 4,500 feet. Let's jump over to North America. And as you can see, the turbulent zones are kind of around the coast, the west coast, east coast, kind of that Mexican Gulf Coast as well. And same time of ordeal going up to about 4,400 feet. The triple X's mean the same thing, that it's just below 25,000 feet. So those green lines that you see everywhere, the green arrows, are actually the jet streams. And by green, it actually means that they are above 80 knots. So if you look under each of those green arrows, there's a box, and that's actually telling you the feet, and that's in flight feet, so in hundreds. And on those lines, if you see the double green dash marks, that actually means there's a change in wind speed over 20 knots. Also, it tells you the tropopause, and if you kind of see those baseball diamond things that have an L or an H in them, those are showing areas of relatively high and low tropopause in hundreds of feet. So the three type of tropopause are the rectangular boxes, which are in hundreds of feet, and then the low and the high boxes that look like baseball diamonds. And all those are showing is that the centers are of high and low tropopause. So rectangles are just normal, and then like I mentioned earlier, high and low. So those are the three tropopauses. So then again, jumping down to South America, you can see the three types of tropopause here as well in those different boxes. You can also see the turbulence in those yellow dashed hash marks. And my favorite part of this prognostic chart, if you look at the very top of the screen, kind of in that middle America area, you can see volcanic activity. There's like 3 volcano symbols there. If you look up there, looks like it says Popocatépetl and Fuego. And unfortunately on this map, we don't get to see anything cool like tropical cyclones or severe squall lines, unfortunately. And again, we also don't see any sand or dust storms or radioactive material. But yeah, thanks for watching. That's the basics of low-level prognostic charts and high-level. So thanks again for watching.